In these carbon, the removal of this Br, and we are getting this carbocation. In this also, hello everyone, welcome back to PLUTUS IAS. So we were discussing regarding this PYQ series. In the previous few videos have been uploaded regarding this PYQ of this UPSC Optional Chemistry. So today we are again with the next question of this series. In this question, it is being given a reaction over, we are given the base and some rate constant is being given. The rate of this reaction is being determined as KH, and the another reaction, that let's say it is first reaction and this is second reaction. In this reaction, we will see that rate is given as KD. So if you visualize over here, that the only difference between these two reaction is that here the benzylic position hydrogen is there. In the second reaction at the benzylic position, we are having deuterium. Hydrogen and deuterium, the only difference is the molecular mass difference. So, and it is being observed that rate of KH by KD is 7.1, which means the first one reaction is quite faster and second one reaction is very slow comparatively. If you see over here, KH by KD is 7.1. So we have to, on the basis of the data, we have to predict the mechanism, which mechanism this reaction is going to follow. So generally, this is the elimination is going to take place. So the most possibility is either E2 or E1. And we know strong base is given. Strong base is given, that give us an idea that most probability is going to follow the E2 mechanism only. So this is the reaction which is being given over here. The first part, we will firstly we will follow the E1 mechanism. In the E1 mechanism, what happens? We know that firstly this Br leaves over here this substrate. We are having this substrate like this hydrogen, and this Br it leaves over here. And a formation of carbocation. And a formation of carbocation takes place, and this E2O negative come in the place. This E2O negative comes in the place and abstract this proton, and this comes back over here, and we get a product like this. This is the product if you visualize the same as this one. In the same way, the same pathway will be followed by the another. If you visualize this for deuterium, this is our deuterium. If it is following the E1 pathway, over here Br, so again the same thing. This is our rate determining step, slow step, removal of this bromine and formation of a proton carbocation at this place. And then what will happen? This deuterium again will be abstracted by E2O negative. This will be abstracted by E2O negative over here, any one of them, and we will get a product like this. The product we can visualize CS3 CD double bond. We are getting the same product over here, like this, and the same over here. So by the E1 also we are getting the same product. And if we follow the E2 mechanism, if we place over here the E2 mechanism, so what will happen? This base will attack at this hydrogen. Simultaneously, this will comes over here and this will leave. This is the E1 mechanism. Only the one-step mechanism will take place. In the one-step mechanism, this comes over here, abstract this proton, and this is the overall step. E2 mechanism, sorry. So all these base also and this substrate also, both are taking part in this rate determining step. So this, and we get a product like this. In the same way, for the second E2, if we place E2 at this carbon, it will comes over here, attack at this carbon deuterium, and it will leave like this. So this is being produced over here. So if you see over here, in these carbon, the removal of this Br and we are getting this carbocation. In this also, removal of this Br and we are getting this carbocation. So in this rate determining step, we are not getting any essential information or any beneficial information which can tell us that yes, the rate of this first KH will be going to higher by this E1. So we can say E1 is not possible. But if we visualize the E2 reaction, if we visualize this E2 reaction over here, in this E2 reaction, the rate is dependent on both this substrate and this hydrogen. Now it is taking part in this rate determining step. This is removing, and this is a primary isotopic step. It is being known that like this. So in this primary isotopic effect means it will take part in the rate of reaction. There is a primary isotopic effect. So what it is going to happen over here? This CH bond, it is thicker as compared to this CD bond. And this we have already seen in this hyperconjugation of CH is more as compared to CD. Due to the strength of this CD bond is quite more as compared to the CH bond. That's why this will be break down quite easily as compared to the CD bond. That's why the rate of this will be quite higher as compared to this. So we can say by this phenomena that this CH bond, they are taking part in this rate determining step. That's why this reaction is being followed through the E2 mechanism. This reaction is following the E2 mechanism. Which mechanism is being followed over here? E2 mechanism being followed, and we have justified by the primary isotopic effect. We have justified by the primary isotopic effect, and in this there is a secondary isotopic effect. This hydrogen is changing, but it is not taking part in the rate determining step. So that's all for this question. We will come again with the next question, and you can also tell me if you need some more topic, if some special topic you need that I need to be covered up regarding your UPSC preparation of chemistry optional exam. That's all for today. Thank you.